Have you ever wondered what's the point of having a paper straw that disintegrates before finishing our drink? Or if recycling is being preached everywhere, why are there still plastic pollution happening in our ocean?
When defining the material criteria, we focus on essential performance properties. These include moisture resistance to prevent microbial contamination, oxidation resistance to protect against chemical degradation, and corrosion resistance to ensure long-term durability. In addition, sustainability is a key consideration, emphasizing recyclability and environmental responsibility.
Besides, we should also consider some commercial trade-off factors, such as transport and the consumer convenience.
Because it's flexible, it can be shaped to fit more efficiently in space. However, for sustainability-wise, although it requires lesser energy to refine plastic, which helps decrease carbon footprint, only a small amount of plastic is being effectively recycled, as it can be contaminated with food, which makes it hard to recycle, and also the fact that plastic doesn't biodegrade. However, overall, plastic is incredibly moisture, oxidation, and corrosion resistant out of all the other food packaging materials.
Why paper and cardboard? The first point covers the distinctions between them. Essentially, we group them as paper-based materials. They are a sustainable option coming from renewable resources and are easily recyclable. It's also cost-efficient and highly available for non-barrier use. For weaknesses, paper has poor moisture resistance, so it requires an internal barrier. It also has poor oxidation resistance, so it needs lamination. Corrosion isn't applicable as it's used for dry goods. The current solutions are adding a thin layer of plastic laminate and adding a foil or inner plastic bag for moisture and oxidation respectively. These solutions lead to challenge recycling as plastic and foil layers are tightly stuck to the paper, so it can't be separated. It also causes negated biodegradability as the coating prevents the entire package from fully decomposing.
Metal packaging is selected for its high barrier performance, thermal stability, and cost efficiency over the product lifecycle. Its durability and resistance to moisture and oxygen ingress contribute significantly to extended shelf life. In addition to performance, metals offer functional advantages such as ease of opening, structural rigidity, and low transport weight. The infinite recyclability enables closed-loop material use. However, primary metal production remains energy-intensive and contributes to greenhouse gas emissions, making recycling pathways essential to reduce environmental impact. Metals exhibit low water vapor permeability, excellent oxidation resistance, and corrosion protection through passive layers or coatings. While these properties ensure product integrity and microbial safety, migration of residual monomers or coating degradation products poses a potential risk, requiring strict regulatory compliance and material selection.
Glass helps preserve food by increasing shelf life without losing its quality and preventing bacterial growth. It ranges from low to high cost, such as preserved food and wine. Glass can be utilized for sustainable purposes because it is reusable, recyclable, and long-lasting. Here's an example of glass food products being packed in a corrugated box with a fragile label to alert the sender before delivery. In this table, glass is a non-porous material whereby the liquid or air cannot pass through the glass. Glass prevents oxidation from entering the food. However, the CAT specification need to be done accurately. Moreover, it is resistant to corrosion due to chemical inert stability.
Wood is chosen not for broad performance but because commercial appeal to specific, often premier market. It offers a unique, authentic, and brand identity that is available for marketing and differentiation. Also, wood is a renewable, carbon sequestering, and often biodegradable material. At the same time, wooden packaging is typically strong, stackable, and reversible, which can be efficient for bulk transport despite potentially higher individual unit weight compared to plastic or cardboard. Wood doesn't perform well in moisture, oxidation, and corrosion resistance. Producers are trying to solve these problems through different ways, such as driftwood like plywood, creating a thick continuous film on the surface, or reacting wood with acetic to change the chemical structure of the wood.
We found there's only a spectrum of trade-offs. If safety and preservation is the priority, we rely on glass and metal. They are ultimate inert barriers but come with the highest cost and logistics penalty due to their weight. If cost and logistics is the priority, plastic wins. However, this cheapness comes at the cost of poor oxidation resistance that must be engineered back in with expensive lamination.
The trade-off between food safety and packaging requirements is crucial in the production process to meet the consumers' and producers' needs. Although glass and metal undergo high-intensity production, this results in high emissions, but both materials can be recycled. Lastly, food package with plastic and paper is mainly discarded in the general bin, thus contributing more landfill waste.